Hey everyone, welcome to Cogito Code. So in this video, we are going to solve some questions on stack and queues. Previously, we have learned about stack and queues in one conceptual videos. Before that, we have learned about arrays and linked list. So what we'll be doing, we'll make one conceptual videos in which we learn the concepts about the particular data structure. And in the next video, we'll try to solve some questions, some previous year grade questions, sample paper questions, and other questions which may, the similar pattern question may come to the GATE examination. So this is one that kind of a video. We'll encourage you to solve more questions apart from these. These are just some sample questions and previous year questions which has come in the GATE with the same topic. So this video will be about stack and queues. And if you have some doubt, you can join our Discord channel. The link is in the description, and we'll show the QR of same. So let's start. So this is the first question. It is saying that consider a sequence of elements. Okay, so there are a sequence of elements given, that is from A0, A1, A2, A3 till A5. Now the following operations are performed on a stack S. So again, need to recall about what is a stack. It is based on last in first out concept, just like a books of stack. Whatever book came last, that will be the first you will pick. Okay, so yeah, and a queue, a little bit about queue based in queue works in first in first out basis. Whatever comes first in the queue, that will be the one who will come out first. Okay, so now we need to follow these particular operations, and then we have some uh, question to answer at the last. Okay, fine. So I denote our stack like this. Okay, this will be our stack. So we can relate with a pile of books analogy, and I have my queue like this. So this is my queue. So start, push the, so first operation is push the elements of A from A0 to A5 in that order into S. So from A0 to A5, we'll push all the elements to our stack. So first come 1, then we'll push 5, then 7, then 8, then 9, and at last 2. Now if you do a pull operation from this stack, this 2 will be which will come out first, because that is in the top. Fine. Then second operation is enqueue the elements of A from A0 to A5 in that order into queue. So in same order, we'll enter them in the queue. So 1, 5, 7, 8, 9, and 2. Fine. Then next is pop an element from S. So we'll remove this top element from the S. So let me just cross it. Then dequeue an element from Q. So we'll remove the top element from Q. Then pop an element from S again. Then dequeue an element from Q. So we are currently here. Then dequeue an element from Q and push the same element into S. So we'll dequeue this 7 and push it here in our stack. Fine. Then repeat operation 7 3 times. So again, we need to dequeue an element from Q and push the same element into our stack. So we'll remove 8, we'll push it here, we'll remove 9, we'll push it here, and then we'll remove 2 and we'll push it here. Then what we need to do, pop an element from S. So we remove 2, then pop an element from S again. So we remove this 9. Then the question saying the top element of S after executing the above operations. So we have done all the above operations, and then top element of stack is this 8, right? So the correct answer of this question will be 8. Okay, let's jump to the next question. So suppose a stack implementation supports an instruction reverse. Okay, so you have a stack, and basically you have two operations or three operations like push, pull, and peek. In push, we add element to the stack. In pull, we remove the element. Now they say that there is an extra instruction or operation that is reverse. What it will do, it will reverse the order of elements on the stack. So let's say your stack is 1 2 3, it will reverse it to 3 2 1. Fine. Now in addition to the push and pop instruction, okay, which one of the following statement is true with respect to the modified stack? Fine. Options are: a queue cannot be implemented using the stack, using this stack. Second is, a queue can be implemented where NQ takes a single instruction and DQ takes a sequence of two instructions. Fine. Third is, a queue can be implemented where NQ takes a sequence of three instructions and DQ takes a single instruction. And the fourth one is, a queue can be implemented where both NQ and DQ take a single instruction each. Fine. So now we have two questions. Can we implement a queue using this stack? If yes, then what will be the complexity of the NQ and DQ? That how many operations it will take to do a NQ operation and how many operations it will take to do a DQ operation. So let's say this is our stack. Fine. Let's say 1 2 3 4, and you know how stack works. It works in last in first out principle. And how does a queue work? Let me remove it for now. The example is not needed. Queue work in first out principle. So whenever we have this stack, and stack will always remove this from the top. Okay, so let's say we enter something 1 and 2 and 3. For when we need to implement a queue, we need to get this element 1 whenever we do a DQ operation. But by default, what stack does, stack will give us this 3. But in this stack, we have another extra operation called reverse. So we can reverse it. So we can simply do this, that 3 came here, 1 came here, and then we can remove the element. Okay. So let's say we do this every time. We need to do this operation NQ and DQ, and we choose to reverse the list whenever we want to do a DQ. Fine. So let me take an example here. So this is our stack. We entered 1 here. Okay. Now 1 is single element, so no matter what we NQ, DQ, what we do, doesn't matter. When we add 2 here, now things will get a little complicated. Now if I need to do DQ, I need to do a reverse. Okay. So let's say I do a reverse. The operation, this will become 2 and 1. Then what I need to do? I need to do a pop operation for this DQ, right? I did a pop operation. So 1 will be removed, 2 is left. Now, should I just leave it as it is, or do I need to reverse the list again? We need to reverse the list again, right? Why? Because let's take a bigger example. Let's say we have this 1 2 3 here. This is our stack. Now we need this 1 because we are creating a queue. So when I do reverse, it will become 3 2 1. I do a pop operation, or so 1 will come out and 3 2 is here. Now if I don't reverse it again, when I do NQ or push again, so what was the original order? Order was 1 2 3. So it should be 2 3, and whenever the new element will come, it should come here 2 3 4. But if I don't do a reverse, then what will happen? It will become 3 2 4. So order is not maintained anymore. So I need to again do a reverse operation. So it will again become 2 3, and then whenever I push again, so whenever I do this NQ operation again, that will maintain this 2 3 4 order. So how many operations I'm doing here for DQ? That will be like 3 operations. Okay, and how many operations in NQ? That will be just 1 operation, right? We can just add it. Okay, this is one way to implement the queue using stack. But what if I say that, okay, I don't want to reverse it when doing this DQ operation? What if I maintain my stack like this, that whenever I want to DQ, I just simply DQ? I don't want to first reverse, then pop, then again reverse, and then DQ. So what can we improvise? How can we improvise? So again, we have this initial one, and again we have to give some complexity to NQ and some complexity to DQ. So let's say again we have this 1 2 3. Okay, and we want that it comes like a queue. So whenever we are doing stack operations, but at the end we want that whenever we push something, so let's say currently my stack is empty, I add 1 is fine. When I add 2, I want it to be like 2 comma 1. So whenever I do a DQ, I can simply do this push operation, pull operation, and I get this 1, because the stack will give me top element, and Q should be Q need to get the first element. When I add 3 here, so it should be like something like this, that it will become 3 2 1. So in this case, my DQ will be just 1 operation, because my first element will be my top element. Okay, but for that we need to do some extra operations in NQ, as you can see. What is that? That let's say there's our, we added this new element 2. Now what I need to do, I need to reverse it. This is, let's say, my initial list or initial array. Okay, let me do it like 2 1. Okay, let's say till this time we have sorted this. So first what I need to do, I need to reverse it first. So a new element which we are entering, that can come in right order. So we'll first reverse this 1 comma 2. Okay, let me write it here. So it will become 1 comma 2. Then what we'll do, we'll add a new element, that is push. So it will become 1 2 comma 3, and then I'll do reverse again. So it will become 3 comma 2 comma 1. Okay, now if we want to add a new element, let's say 4, so again this is our current list, 3 comma 2 comma 1. We'll reverse it, so it will become 1 comma 2 comma 3. Then we'll push, so 1 comma 2 comma 3 comma 4, and again we'll reverse it, so it will become 4 comma 3 comma 2 comma 1. So now DQ is just 1. We just do the pull operation, and that will work as a DQ operation, because again the top element is the first element, or in that same order. But NQ, now NQ taking 3 operations, first reverse, then push, then again reverse. So we can either choose to do it this way, that we take either 1 NQ operation and 3 DQ operation, or we can choose this way to do 3 NQ operation and 1 DQ operation. Now let's go to the options and see which one of the if any of the options satisfy any of this condition. So first option is a queue cannot be implemented using this stack. So as we see that we can implement the queue when the reverse function is present in the stack. So first option is incorrect. Second is a queue can be implemented where enqueue takes a single instruction and dequeue takes a sequence of two instructions. So we have seen both cases. If enqueue takes a single instruction, that dequeue will take three instructions, not two. So again, this is incorrect. Let's go to the third one. The queue can be implemented where enqueue takes a sequence of three instruction and dequeue takes a single instruction. So yes, we had this sequence like enqueue takes three instruction and dequeue takes a single instruction. So this one will be correct. What is the fourth one? A queue can be implemented where both enqueue and dequeue take a single instruction each. So this is not possible, right? So again, the fourth option is incorrect. So the right answer will be third. So let's jump to the next question. That is, consider the queue Q1 containing 4 elements and Q2 containing none. Okay, so this is our Q1 initially, and this is our Q2. Q1 have 4 elements and Q2 has no elements. Now the only operations allowed on these two queues are NQ and DQ. Okay, so in NQ we will have this particular queue and we'll take an element and we'll push that particular element to the queue. And then we have DQ, which will remove the first element from the queue. The minimum number of NQ operations on Q1 required to place the elements of Q1 in Q2 in reverse order without using any additional storage. Additional storage means that we cannot use any extra variables or any extra data structures to store these particular elements. Fine. So this is our final state, that Q1 will be empty and Q2 will have all these elements in reverse order. Okay. So we need to do all these operations, but we need to do these that operations in Q1 and Q operations on Q1 will be minimized. Fine. So let's do this. So let's say this is our Q1, 1, 2, 3, 4, and this is our initial Q2. That's completely empty. What I'll do, and first DQ from here and NQ in our Q2. Okay, so I'll do DQ from here and NQ in Q2. So one will be removed, one is removed. Okay, and we have this one here. Now what I'll do, I'll again do this DQ from here, Q1, and I'll do NQ again in this particular Q. So 1, 2. Okay, and 2 will be removed from here. What we'll do, we'll start the reversing our Q2 from here only. So then I'll DQ our this Q2 and NQ in Q2. So our Q2 will look like something this. I have DQ'd this one and added it to the last. Then I'll add 3. I have reversed the list. Now I'll DQ from Q1 and NQ into Q2. So it will look like something 2, 1, and 3. Then what I do, I DQ from Q2 and again NQ into Q2. So it will look like 1, 3, 2. Then again I DQ from Q2 and again NQ in the same queue. So it will look like 3, 2, 1, and this is not there. Now 3 elements are reversed. What I'll do next, I'll remove this 4 from here. I'll DQ from Q1 and NQ in this particular queue. So it will become 3, 2, 1, 4. Okay. Now I'll again DQ3 and NQ it at the last. So it will become 2, 1, 4, 3. Then again I DQ2 and NQ it in the last. So it will become 1, 4, 3, 2. And again I DQ this 1 and add it to the into the last. So that will become 4, 3, 2, 1. Okay. So if we see all the NQ operations which we have done, all the NQ operations we have done in our Q2. We have done only DQ operations in Q1. So how many operations we done in Q1? None, right? So the minimum number of operations, NQ operations on Q1 will be 0, because we need not to do any operations on Q1. We can simply get elements from Q1 to Q2 and then we reverse the elements in Q2 itself. Okay, so the answer will be 0. Okay, let's jump to the next question. This particular question came in gate 2025 or gate 2024, but in some gate. So the question says that match the items in column 1 with the items in column 2. So column 1 is first in first out, lookup operations, and last in first out. And in column 2 there is stack, queue, and hash tables. So by now you can almost immediately can tell that which will be which. If not, then I'll suggest you to go back and watch the stack and queue video. So first in first out, obviously it is queue. Okay, so P will be connected to 2 second, and lookup operations is something which we have not covered yet, but we'll cover later. That is hash tables. But we can check this R1, that last in first out will be stack. So Q is 3 and R is 1. And which of the particular options satisfy this condition? That is the first option. So this will be correct. Okay, let's go to the next question. So this question says that consider the following sequence of operations on an empty stack. So we have an empty stack like this. Then so what operations we need to do? Push 54, fine. Push 52, fine. Then pop. Okay, so we'll remove this 52. Then again push 55 and push 62, and then S is equal to pop. So S will be the last element, that is 62. So and we'll remove it from here. Then we need to do some queue operations in an empty queue. So let's say this is our empty queue. Okay, so we'll do 21, then NQ 24, then we'll do a DQ operation. So 21 will be removed. Then we'll do a NQ operation 28, and then we'll do a NQ operation 32, and then we do a DQ operation again and store it in the variable Q. The Q will be 24 and we'll remove it from here. And the value of S plus Q is asked. So S plus Q is just 62 plus 24. That will be 86. Okay. So that will be the answer. And now let's go to the next question. And seems like a lengthy one. So let's read it out. Let S be a stack and Q be a queue supporting the following operations. Stack operation, stack will push, and this question and the previous question also came in some gate exam. Okay. And then pop will remove the element from the stack and return the removed element. Q again, and Q will add this particular D element into the queue, and DQ will remove element from the queue and return the removed element. Now suppose initially elements A, B, C, D, E, F, and G are pushed onto stack N in reverse order. Is that starting from G? Okay. And then following sequence of operation is performed on stack and queue. Okay. And what would be the value result after completion of operations? Fine. So let me have a stack. This is our stack. And we have pushed these operations from G to A in reverse order, that is starting from G. So first G will go in, then F, then E, then D, then C, then B, and then A. Okay. Then we have a queue. So let me draw a queue here. So the following sequence of operation is perform stack and S and Q. So what is the first operation? That will enqueue in the queue with whatever comes from s dot pop. So s dot pop will give us A and we'll enqueue it here. Second operation is same. So we'll remove the B and add here. Third operation is same. So we'll remove C and add here. Fourth operation same, and fifth operation is also same. So we'll remove this from here, add it here. We'll remove this from here and add it here. Okay. Then we need to do this is sixth operation, that is saying s dot push q dot dq. So the top element or the first element from the queue, will remove it and push it to our stack. Then same operation we have to repeat again. So we'll remove B and add here. Okay. Then what we'll do result is equal to s dot pop. So whatever the latest element in the stack or the last element in the stack is, that will be popped out, and that is B. Okay. So what will be the result value of result after completion of operations? So the operations completion value will be B, and that is the answer. Okay. Let's go to the next question, and this also came in GATE 2024. The question is saying the fundamental operations in a double-ended queue DR. So I have talked about what is a double-ended queue and how does it work in my stack and queue video, but a little brief summary that in normal simple queue, we enqueue from one side, right? We enqueue from this side and we dequeue from this side. Okay. So whenever we need to add an element in the queue, we'll add from the rear, and whenever we need to remove an element from the queue, we'll remove it from the front side, right? Just like a movie queue or ATM queue, all of those works. What happened in a double-ended queue, that you can do both operations, like you can do NQ and DQ from both the sides. Fine. So these are the operations. Insert first means insert a new element at the beginning of D, right? This operation is not available in our simple queue because we can only add new elements in the last. But in double-ended queue, because we can do both operations in front and the last, we can do so. And insert last, we add a new element at the last. Remove first, we'll remove the element from the first, that is like our normal queue, that is DQ. And remove last, we'll remove the element from the last. Fine. Now in a empty double-ended queue, the following operations are performed. So some operations are performed in a double-ended queue. So let me have a queue here like this. What are the operations? That insert first 10. So I'll simply add 10 here because it is empty. So insert first, insert last, no matter. Then insert last 32. Okay. Then remove first and store it in a variable A is equal to 10, and I'll remove this from here. Then I'll do insert dash 28, insert dash 17. Then I'll do remove first and store it in the same variable. So a will be overwritten, right? Initially it was 10, then now it will be 32, and we'll remove this. Then remove last and again store it in the a. So we'll remove this from here and store it here. Okay. And what is the value of a? So the value of a will be 17. Okay, and this was the question of GATE 2024. Fine. Let's go to the next question. Okay. So in this question, it is saying that assume that S is a stack and Q1 and Q2 are two queues which support the NQ and DQ operation. Consider the following pseudocode for implementing the pop and push operation on S. So this is the push operation. There's some operations given, and this is the pop operation. Now, which of the following option for the function A, B, C, and D would correspond to correctly implementing the push and pop operation on the stack S? Okay. So two concepts. If you have seen the previous questions, that we have implemented a queue using stack, if you do remember. Now, what was the trick there? Trick was that we had a reverse operation given, right? Now, in this case, we didn't have a reverse operation given. But we have seen another question that we can reverse the element using two queues, right? We have did that question where we had this 1, 2, 3, 4, and we need to get these element in the reverse order, like 4, 3, 2, 1. So now we need to perform both the operation, because the reverse operation is not given in this case. That's why we have given two queues, Q1 and Q2. So we can perform this reverse operation in Q1 and Q2. Fine. So in push, we have given some operations like A and B and C, and then pop is D. Fine. So what we need to do? We need to implement a stack. How does a stack work? Stack is last in, first out. We have given two queues. Two queues are first in, first out. Okay. So again, as we have seen that, let's say we in the previous question we had this queue thing, but what we did, we reversed it. Like, remember the operation where we were doing this three operations for NQ and one operation for DQ, right? We were taking this element first, we were reversing the list, then we were adding the element, and then again we were reversing the list. So our order get maintained, and whenever we want to do a DQ operation, we can do this and big of 1. So if you see this pop operation, we are just removing this D of Q1. So this is just one operation, and you can figure it out that it must be a DQ operation. It can't be NQ, right? You are doing a pop. So in pop, you need to remove an element from the queue, which is behaving like a stack, and then give it to some variable, right? So it cannot be NQ. It has to be a DQ operation. So D is simply a DQ operation that is there. Okay. Then if we see here, now let's go to push, and remember that reversing analogy, we are doing it here. So we have A, Q2 comma X. So we have these two Q, one is Q1 and other one is Q2. So we are doing this q2 comma x, and cause there is an additional element x, so you have to push it somewhere, right? You can't take an additional element and perform a dq operation. So cause you are putting this x into q2, so a must be a nq operation. So a is definitely a nq operation, and you have added this x into q2. Now while q1 is not empty, q1 is not empty, so in this case q1 is just empty, and then you swap q1 and q2, so this element will become this list will become q1, and this list will become q2. So when you do this return q1, so you will just remove this element. Now we'll just perform some more operations so you can see how the whole circle is working, how this push operation is working. So let's say I add one more element y. So first what will happen, this q2 comma x will happen, so y will come here. Then what I do, when q1 is not empty, b of q2 comma c of q1. Okay, so this b will be again an nq operation. Why? Because if you see the signature, what is this? A of q2 comma x. q2 is a q and x is an element. Again we are doing something with b, so q2 is what? q2 is a q. And what is this c of q1? c of q1 will be a dq operation, which will give us some element, so there will come some y or something. Okay, so let's see what will happen. So we got our answers already, that b is a nq operation and c is a dq operation, but how it is working, let's see. So we'll do this c of q1, so this x will be removed and it will come here like b of q2 comma x. And what we'll do then, b of q2 comma x, so it will just remove add it here like this. Okay, and next what we'll do, we'll swap this, so q1 will be this and q2 will be this. Okay, and whenever we want to do a q1, then we can simply return it from q1. So these are our operations there. And which of the particular option match? So a comma b should be nq and c comma d will be dq. That is our first operation or first option. Okay, let's go to the next question. So here our long pseudocode is given, and at the end we have to do some, that what is the value of sum or something. Okay, so let's go through this pseudocode and see what happens. So create empty stack as, okay, empty stack created. Now set x is equal to 0, x is equal to 0, dag is equal to 0, lag is equal to 0, and sum is equal to 0, sum is equal to 0. Fine. Push x onto s. Okay, we pushed it here. Now while s is not empty, so until the stack is not empty, we have to keep running this loop. And if nag equals 0, so yes, nag is equal to 0, then x is equal to x plus 1, so x will become 0 plus 1 1. Okay, and remove it or let it be written, and push x onto s, so we'll push it here. Okay, now if x equals 8, then we'll do the set flag to 1. So obviously we are not near 8, we are just 0. If nag equals 1, then do some operations, but that is again not the case. Okay, so we'll skip this also. So again, we'll keep doing this. We'll come here at this particular point and see if nag equals 0. So yes, it is 0. Then we'll again increment the x. So x will become 2 and we'll push it here. And again, the x is not equal to 8. So this will not enter here. And again, the flag will not become 1. So this loop will not execute. So we'll keep doing it. This particular loop 3, 4, 5, 6, 7, and 8. Okay. When we'll do this 8th time, then we'll come to this particular if condition and we'll say that, okay, now x is equal to 8. Now what I need to do? So what it will do? It will say now your flag will become 1. So now flag is 1. And then we'll come here and again this particular if condition will execute that, okay, now flag is equal to 1. So what I need to do? So you do this pop of s. Okay, x is equal to pop of s. Give me 1 second. Yeah, x is equal to pop of s. So I'll remove this element from here and store it in x. That was already 8, but it's fine. And then if x is odd, then pop s. So x is not s. Sorry, x is not odd. X is 8. That is even. So we won't do this pop s thing. Instead, what we'll do this set sum is equal to sum plus x. So sum was initially 0 and we'll add, so sum will be 0 plus 8 because our x was 8, and then we'll output sum. Okay, so our current sum is 8. And what are our variables? So I'll remove the variables. Our x is currently 8, so I'll remove this. Our flag is currently 1, so I'll remove this, and our sum is 8. So I'll rewrite them here. Flag is currently 1, x is currently 8, and sum is also 8. And I'll remove rest of the variables from here. Fine. Just a recap what we did till now. We set these x is equal to 0, flag is equal to 0, sum is equal to 0. We push this x onto s, that was 0. Then until this stack is not empty, we need to do this loop thing. Then we see that if flag equals 0, we'll just increment x and push it into the stack. And we see that this if condition will only satisfy when the x is equal to 8, and then only the flag will be 1. And this condition will only enter when flag is 1. So until the 8 is not x is not 8, we can't do anything with these two conditions. So we keep iterating through this if condition where we were incrementing our 1 x, incrementing x by 1, and we keep pushing it into this stack. So now we have 0 1 2 3 4 5 6 7 8. On 8 we check this, that if x is equal to 8, so we set our flag from 0 to 1. Then if flag equals to 1, which was in this case, we pop s, that is 8. And now if x is odd, then we need to do this pop thing, but x was even, so we added it here, that we did this something. So these are our current variables. I'll remove these from here. Okay, these are our current variables, and this is our stack. 8 is not there. Now we still need to keep iterating through this loop until our stack is empty. Okay, so if you see, this loop will not enter again because our flag is 1 and there is nowhere where our flag is resetting into 0. Same way, okay, this x is equal to 8 is there, and it is just setting our flag to 1. So we don't need to worry about this condition also, but snag is already 1. So we will do this only. Let's focus on this. So again, the flag is 1 and this is our stack. So we again pop one element, that is 7, and store it into the x. So x will become 7, and if x is odd, then pop s. Just remove one element. We are not storing it anywhere. So if x is odd, then remove, just do a pop operation. So we do this, and what then we'll do, we'll set sum is equal to sum plus x. Sum will be 8 plus 7, that is 15. So these are our new variables, x is 7 and sum is 15. Again we'll go through this, and these two new variables have been removed. Again we'll do this pop, x is equal to pop of s. So new s will be, x will be 5. Okay, and if x is odd, which it is, then we'll again do a pop operation. So we'll remove this 4, and 5 were already removed. And we'll do this sum. So sum is equal to already sum, that is 15, and the current x, that is 5. So it will become 50, and our stack will look like this. Then again we'll do this pop operation, x is equal to pop s, and we'll get a 3. And again if x is odd, pop s. So we'll remove this 2, and 3 was already removed. And again we'll do this sum is equal to 20 plus 3, that is 23. Okay, then the loop continues. X is equal to pop of s, that is 1. So our x will be 1. X is odd, yes, so we'll remove this 0 also and 1 also, and we'll do this set sum is equal to sum plus 1. So sum will be 23 plus 1, that is 24. And now when we go to this loop again, it will check if s is not empty, but in this particular case our s is empty. So then what we'll do, we'll just simply return this output sum, and what was output was 24. That is our sum. So the value of sum output via program executing the pseudocode will be 24. Okay, and this question was asked in GATE 2025. Fine. So these were the questions for this particular video. These were just some sample questions. Need to solve many more such questions to be fluent. And you can see these are not very tough questions. These are decently easy questions. You can master them with practice. Okay. Now, when you are solving your questions, new questions from yourself, then if you are having any doubt, then you can join this Discord server of ours, and you can ask your doubts here, not just for Python DSA, but for other subjects as well, like DBMS, machine learning, AI, linear algebra stats, and so on. You can interact with your peers, discuss the gate slavers, gate questions, and other things, and we're happy to solve your doubts, solve your queries there. So please join our Discord channel and subscribe, because we'll be creating more such videos on questions, on topics, on concepts. So more videos on PDSA, on AI, on ML will be coming, along with their questions, their concept questions videos. So give it a like, do subscribe our channel, and see you in some next video. Thank you.